Scientists may have just uncovered what's actually inside a black hole, and it changes what every science book says. For years, we believed black holes were endless traps, swallowing light and matter with no escape. But new quantum physics discoveries suggest they might hold something far more shocking. What if black holes don't destroy everything, but instead create entire new worlds inside? Tune in, because this revelation will confirm the existence of endless parallel universes just like ours. Here's the problem. No one can peek inside a black hole. Our lives are way too short for that. As you get closer, gravity intensifies, stretching time itself. If you could somehow survive the crushing forces, you'd watch the universe outside speed up, aging billions of years in what feels like seconds to you. But entering a black hole isn't just about surviving time distortion. It's about making it past the raging, swirling ring of doom known as the accretion disk. This superheated plasma, spinning at nearly the speed of light, would instantly reduce anything to ashes. Before we go any further, what lies beyond a black hole is far more mind-bending than anyone ever expected. And this won't be the only thing that will leave you questioning reality. Unless, just maybe, a special type of black hole with an electric charge could cool things down. Some scientists suggest that quantum noise inside these charged black holes might make their accretion disks less lethal. That means, in theory, an explorer could slip past the burning barrier. But even if they did, a smaller black hole would rip them apart with its brutal gravitational pull. On the other hand, in the heart of a supermassive black hole, gravity could be gentler, possibly allowing someone or something to pass through intact. And what if, on the other side, they found a whole new universe waiting? For a long time, scientists assumed black holes were just voids filled with crushed stars and shattered planets. But recent discoveries suggest they might be something entirely different. Inside certain black holes, light and matter appear to swirl rather than vanish. This could mean that space inside is stretching and reshaping in ways eerily similar to how our universe expands. What if black holes aren't just swallowing everything, but actually creating new worlds? That's exactly what one physicist, Dr. Nikodem Poplawski, thinks. He believes that black holes act like cosmic seeds. Imagine all the matter sucked into a black hole being compressed into an unbelievably tiny point, a singularity. When this point reaches its breaking point, it doesn't just sit there, it bursts, unleashing everything in an enormous explosion. Sound familiar? That's basically how scientists think our universe started, the Big Bang. If Poplawski is right, our entire universe could be the inside of a black hole that formed in a much larger universe. Even crazier? The black holes we see might be growing new universes right now. Here's where things get even wilder. Some scientists now believe that universes don't stay trapped inside their parent black holes. As the black hole grows, it could push the new universe outward through a wormhole, like a tree sprouting a new branch. This wormhole would act as a hidden gateway between the two realities, keeping them connected. What's on the other side? A whole new cosmos with its own galaxies, stars, and maybe even life. Poplawski didn't just stop with theories. He went a step further and found actual evidence. He pointed to the way everything in space spins. Galaxies, stars, planets, and even black holes themselves. He suggested that if our universe came from a spinning black hole, it should still carry that original rotation. And guess what? Studies show that galaxies in our universe don't all spin in the same direction. Some twist left, some twist right, just as you'd expect if they were born from a spiraling force. But what if black holes go even deeper? Some physicists at the Perimeter Institute for Theoretical Physics believe our universe could be the three-dimensional edge of a black hole in a higher, four-dimensional space. Think about how a two-dimensional accretion disk surrounds a black hole in our world. If we flip the dimensions, Our universe could be the three-dimensional disk of a four-dimensional black hole. This idea suggests that a giant star in a four-dimensional universe exploded, forming a colossal black hole. Its debris, the glowing, swirling remains of that explosion, became our universe. The problem is, we can't directly see a four-dimensional world. To us, it would look like incomprehensible distortions, just as a three-dimensional object would appear as strange shadows to a two-dimensional being. But if this theory is true, we might be able to find evidence. Scientists predict that a four-dimensional universe could subtly affect the radiation left over from the Big Bang. If we find weird fluctuations in this cosmic background radiation, it could be the smoking gun proving that our world is just a tiny part of a much larger hidden reality. And it doesn't stop there. In 2022, astronomers caught a black hole doing something they never expected. It wasn't just absorbing light, it was actually lighting up nearby stars. This means black holes could be more complex than just cosmic trash compactors. Scientists are now building holographic and 3D models of black holes to test these radical ideas. Every time we think we understand black holes, they throw us another curveball. What if black holes aren't the end of everything, but the very beginning of something new? Scientists have done more than study black holes. They have started creating tiny ones in labs. Scientists have been playing with forces beyond imagination, creating artificial black holes in the lab. A group of researchers in Israel has managed to generate microscopic versions using rubidium, proving that Stephen Hawking was right about black hole radiation. That alone is mind-blowing, but they are not stopping there. They want to uncover even more about these cosmic monsters, maybe even find out if there are hidden universes trapped inside them. But let's step back for a second. Should we really be messing around with things that have the power to swallow reality itself? It's no news that black holes are the ultimate cosmic vacuum cleaners, devouring anything that dares come too close. And now we know that one of these terrifying beasts is lurking nearby, just 1,000 light-years from Earth. That might sound like a safe distance, but in space terms, it's practically in our backyard. To put it in perspective, the black hole at the center of our Milky Way is 25,000 light-years away. This means we now have a silent, invisible predator watching from much, much closer. But here's the real question: what else is hiding in the dark? For those who need a quick refresher, black holes are the remains of massive stars that ran out of fuel. When a star that is 8 to 15 times the size of our Sun collapses, it either explodes into a supernova or simply shrinks into a black hole, pulling everything inward with an unstoppable gravitational grip. The worst part? Not even light can escape, which means these things are practically invisible. The newly discovered black hole found in the Telescopium constellation was spotted because of the way its neighboring stars were behaving, almost like they were being slingshotted around by something unseen. And just like that, we learned that our galaxy might be full of hidden monsters we haven't even noticed yet. This particular black hole is part of a 3-star system called HR 6819, where 2 visible stars are dancing around something completely dark. When scientists looked closer, they realized the inner star was being pulled at insane speeds, making it obvious there was a hidden force at play. That force turned out to be a black hole around 4 times the mass of the Sun, barely 25 miles wide, yet strong enough to control 2 entire stars. And here's the part that should make you stop and think: if we found this one by accident, how many more are waiting to be discovered? The black hole in HR 6819 is quiet for now. It's not devouring anything in a dramatic display of destruction, which means it's even harder to detect. But just because it isn't active doesn't mean it's harmless. There could be millions of black holes scattered across the Milky Way, and we've only detected a tiny fraction of them. Before this, the closest known black hole was 3,000 light-years away. Now we know they are much closer than we ever imagined. Take Cygnus X1, one of the first confirmed black holes, located just over 6,000 light-years from us. It's a monster with nearly 15 times the mass of the Sun, spinning at an insane speed while pulling gas from a nearby supergiant blue star. As it feeds, it creates a swirling ring of fire, a deadly accretion disk that shoots out high-energy radiation. These things aren't just floating around harmlessly, they are actively reshaping space itself, and that's just the ones we can see. Back in 2019, we finally got the first direct image of a black hole, sitting inside the massive galaxy Messier 87. This was no ordinary discovery. The black hole in that photo is an absolute beast, measuring a staggering 24 billion miles across. That's 3 million times the size of Earth, and if that isn't terrifying enough, it has a mass 6.5 billion times that of the Sun. While it's thankfully over 50 million light-years away, it makes you wonder, how many more of these giants are out there, hiding in plain sight? Scientists believe there could be hundreds of millions of black holes scattered throughout our galaxy alone. Let that sink in for a moment. We used to think they were rare, but the truth is, they might be everywhere. The only reason we don't see them is that they aren't feeding right now. But what happens when one wakes up? Now that we know black holes are nearby, scientists have found a way to capture their image for the first time. For years, scientists dreamed of capturing an actual image of a black hole, but the technology just wasn't there. They always knew that a bigger telescope meant better resolution and more light. But how do you build one big enough to see something as elusive as a black hole? The solution wasn't to create a single giant telescope, but to link many smaller ones across the world. They called this setup the Event Horizon Telescope, and by synchronizing their signals, they turned Earth into one massive lens. With this, they set their sights on something terrifyingly close: the supermassive black hole at the center of our own galaxy, Sagittarius A. Here's where things get strange. Scientists expected to see a blazing ring of fire around the black hole, but instead, it looked smaller and dimmer than it should be. That's not just odd, it's unsettling. If black holes behave differently than expected, then how many other things do we not understand? Even more alarming, there could be black holes lurking much closer than anyone ever imagined. Some estimates suggest that one could be within 1,000 light-years of Earth, hiding in the shadows where we least expect it. The problem with black holes is that they don't announce their presence. They don't glow or shine. They simply pull in everything around them: light, gas, even entire planets. If one were to drift into our solar system, we wouldn't even see it coming. Instead, we'd notice strange disruptions: planets shifting in their orbits, asteroids being flung in odd directions, the sun's light bending unnaturally. And by the time we realized what was happening, it would be far too late. One terrifying discovery is the black hole HR 6819, a stellar mass monster that moves rapidly through space. Unlike the supermassive black holes at galaxy centers, this one is untethered, a rogue predator wandering the cosmos. These moving black holes are practically invisible, blending into the vastness of space. Could one be heading our way right now? Scientists admit that if it were, we probably wouldn't know until it was too close to escape. But let's zoom out, way out, to the biggest and brightest objects in the universe. In 2019, astronomers spotted something shocking: a 13-billion-year-old light from a distant quasar. Quasars are basically cosmic lighthouses powered by black holes, but this one was special. It was so bright, so ancient, that it completely rewrote what scientists thought they knew about the early universe. Named Ponua Ena, this quasar hosted a black hole that was already unimaginably massive just 100 million years after the Big Bang. That's a huge problem because black holes aren't supposed to grow that fast. The size of this black hole defies logic. For it to exist, it must have started as a giant, a black hole seed of at least 10,000 solar masses, something no scientist thought possible. Normally, black holes grow by swallowing stars and gas over billions of years. But Ponyoaina's black hole somehow skipped the slow-growing phase and became a behemoth almost instantly. How? No one knows. And if something like this could form once, could it have happened again? Maybe even closer to home? Understanding this ancient quasar could unlock one of the biggest cosmic riddles: how the first black holes formed. Before galaxies, before even the first stars, there were black holes. But if they came first, what created them? Scientists believe that during the epoch of reionization, around 400 million years after the Big Bang, the universe transitioned from darkness to light. Hydrogen gas became ionized, allowing the first stars and galaxies to form. But the discovery of Ponyoaina suggests black holes were already thriving before this process even started. That changes everything. The more we look, the more terrifying the universe becomes. Black holes don't just exist at the edges of the cosmos. They're scattered everywhere, unseen predators lurking in the dark. Some, like Sagittarius A, sit quietly at the center of galaxies. Others, like HR 6819, drift through space undetected. And then there are the ones we haven't found yet, the ones that could be creeping closer at this very moment. Scientists track black holes by observing the movement of stars around them. When a star speeds up, slows down, or bends in an unnatural way, it usually means a black hole is nearby. But this method only works if the black hole has something to interact with. If it's floating alone in deep space, it leaves no trace. So how many are out there, lurking unseen? And what happens when one gets too close to Earth? Even with the first real image of a black hole, there is still much to learn about how they shape the universe. To get a sense of just how powerful these things are, let's talk about what happens when an object gets too close. As matter spirals into a black hole's pole, it heats up to millions of degrees, unleashing X-ray light that screams across space. Gravity here is absolute. Nothing, not even light, can break free once past the event horizon. And yet somehow we've still managed to spot only a handful of young black holes, despite the thousands of galaxies swirling in the universe around us. The reason? Light takes time to travel. Looking at these cosmic titans means peering back into history itself, into an era long before our world even existed. The formation of black holes is another cosmic riddle. One idea suggests they were born from the first generation of massive stars. These enormous celestial giants, made up entirely of hydrogen and helium, ballooned to sizes hundreds of times greater than our sun, but they were doomed from the start. Their lives were brutally short, ending in cataclysmic explosions so powerful that they left behind only their dense, inescapable cores, black holes. But there's another possibility. Some scientists argue that black holes didn't come from stars at all. Instead, they believe these gravity wells formed from gigantic, unstable clouds of gas that collapsed in on themselves billions of years ago. This would explain how we have black holes that date back to the dawn of time itself. Still, for all the equations and theories, we barely understand these monsters. Take TON 618, the largest known black hole, with a mass 66 billion times greater than the Sun. Let that number sink in. 66 billion times. That's a force of nature so immense that it warps reality itself. And yet, black holes remain an unanswered question, terrifying, fascinating, and utterly beyond our grasp. But before you start worrying about getting sucked into oblivion, relax. NASA assures us that no black hole is close enough to pose any real danger to Earth. Despite their massive gravitational pull, they aren't cosmic vacuum cleaners hoovering up galaxies on a whim. Still, scientists have spent decades observing what would happen if something, say a star, did get too close. The result? A gruesome fate called spaghettification. The gravitational pull of a black hole would stretch an object vertically while crushing it horizontally, essentially turning anything that falls into a long, thin strand of atomic spaghetti. And time? time itself warps near these voids. If you were falling in, an outside observer would see you frozen at the event horizon forever, while you, on the other hand, would experience an instant horrifying plunge into the unknown. This all leads to an unsettling question. Could our sun ever become one of these cosmic nightmares? Thankfully, no. The sun simply isn't big enough. Instead, it will quietly fade into a white dwarf, its energy spent, its death peaceful. Even if it did explode, it wouldn't create a black hole large enough to consume Earth. Our planet would just keep orbiting the remains as if nothing had changed. Still, black holes do shape the universe in ways we don't fully understand. When they collide, they unleash shock waves that ripple through space, scattering elements like oxygen and carbon, the very building blocks of life. Some even believe that black holes played a role in the formation of our Milky Way galaxy. Did the galaxy form around a black hole, or did black holes emerge after the galaxy took shape? No one knows. But one thing is clear, without these cosmic monsters, the universe as we know it might not exist at all. And then there's Stephen Hawking, the legendary physicist who shook up everything we thought we knew about black holes. His groundbreaking work suggested that black holes aren't eternal. Thanks to a phenomenon known as Hawking radiation, black holes slowly lose mass over time. You see, space is never truly empty. It's a seething froth of tiny particles appearing and vanishing in an instant. When one of these particles gets sucked into a black hole, its twin might escape, stealing a tiny bit of the black hole's energy as it does. This slow, imperceptible leak means that eventually, even after billions of years, a black hole will shrink away to nothing. So what does all this mean for us? For one, the black hole at the center of our galaxy isn't as terrifying as it sounds. Sure, it's millions of times heavier than the sun, but it has already swallowed up most of the stars in its reach. Even if it keeps feeding on stray cosmic debris, it can only grow so much. Galaxy collisions might make it bigger, but they won't send it rampaging through space, devouring planets. And remember, the most distant quasar we've detected, Panirana, is still unfathomably far away. Whatever happens out there in the deep void, it won't be knocking on Earth's doorstep anytime soon. Is a black hole just a cosmic trap? Or could it be a gateway to another universe, maybe even a new reality? Tell us what you think and remember to like and subscribe for more.